Sorry. This is the first of the second semester units, and it does follow on partly from my first semester unit. We use examples in order to teach general concepts. So these are actual clear examples of pollution, and we're using these to teach concepts and skills around measuring and predicting the pollutant controls on mobility and transformation. We start off by, first of all, defining what pollution is, which is more philosophical than most of the things that are done on the course, but it's quite necessary in order to set all of the work in context. We need to also put it into an economic context. I think that the best thing I could do is to share my screen with you, because could you just let me share the screen? Because this will also allow you to see the learning environment that we've been talking about. So this is the learning environment that we use, which is called Blackboard. And there's a home page for the unit. There'll be an introductory video, and then the learning materials are there week by week. And in this first week, we do have this bar. A critical figure for us when we come to any kind of pollution studies, we'll be going through this, is relating it to economics. And this figure is one that's central to that, which is working out the benefits of remediation of pollution against the costs. And this really drives all of the work in pollution and environmental control, because you're trying to work out whether it's beneficial or not to do it. And all of that in the end is set against real costs. We'll have some arguments about whether you think that's an acceptable thing to do or not. But that's generally the process that goes on. And then if I go back to learning materials, the other things that we cover are, we deal with natural processes and how they're changed by the impact of pollution. We study particularly water. Paul's covered some air pollution in the first semester, but we're covering mostly water and the transformation and mobility of pollutants in water. So we look at water chemistry particularly, and we define the controlling gradients that control the behavior and speciation of pollutants on this planet, and largely their oxidation, reduction, and pH gradients. And we'll look at carbonates, which are particularly important as the main control on water quality, and more important now because of carbon cycling as well. So the standard section on carbonates has become more and more important over the years. And then we'll look at the interaction of water with earth materials, which is responsible for mobilizing many of the pollutants that you'll be aware of, nitrates and phosphates and metals. And if I could, okay, we'll work through. So we have the interaction with earth materials. We look at how pollutant mobility is controlled by sorption onto earth materials, which is probably the most important control for many pollutants. Rather than being controlled by solubility, they're actually controlled by sorption. So we look at sorption, and then we move on to looking at the way that the fluids actually move. So we look at diffusion and dispersion, which Paul's covered in the atmosphere, but we'll look at that in the ground particularly, and in surface waters. And then we'll look at groundwater as well. And we do some very simple modeling of groundwater. And if I come into, this is, show you the way that we actually teach. So a good example, if we look at week 4. So there's learning content with videos and then exercises. And as an example, here's an exercise that you'll do. And you can see that you're taken through the exercise with videos, and there's an image. In this case, there's calculation to be done, and there's an image of that. It's an image of that here. So we go through on a whiteboard, and the image is saved, and you can look at the image. And then there's a video that takes you through the calculation. And then there's a subsequent video that takes you through how to implement effectively a small model in Excel. So there's videos take you through all of that. Okay. So that's the content of the course, and hopefully give you some idea of the way that it's taught, so you can see the learning environment we use and the way that we take you through learning and through exercises as well. The final slide there is the sort of model system that we're making very simple models of, and that's looking at pollutant movement from a landfill. In fact, methane gas moving from a landfill, and whether or not it's going to cause a risk. So that's whether it's going to actually interact with any people or not. It may end up moving under the impermeable layer and seeping into the house on the right-hand side and exploding when the man in the toilet downstairs lights his cigarette. But that's the sort of thing you should be able to predict. Okay, that's enough. Thank you.
Thank you, Steve.